I'll be sharing a multiplication trick, and I'll break the video up into three parts. What is the trick? Why would anyone have come up with this, and how does it work? So first, what is it? So say we want to do 8 times 6. The way this trick works is that you take each of those two numbers and subtract them from 10. So we have 10 minus 8 is 2, and 10 minus 6 is 4. The next thing you do is to take those two smaller numbers, the 2 and the 4, and multiply them together, which gives you 8. Well, we're not done yet. That's not the answer to 8 times 6. The last step is to do a subtraction, and we do that along the diagonal. 8 minus 4 is equal to 4, and so our answer is 48. And it is, right? 8 times 6 is 48. Now, how did I know to subtract along that diagonal? Well, it actually doesn't matter. 6 minus 2 is also equal to 4. So that went pretty fast, right? And there are multiple steps to it. I'm going to go ahead and do another example. If you want to pause it to see if you've got this figured out already and try this on your own first, you might want to do that now. And I'm going to go ahead and jump in and do this. So again, we take both of the numbers in our multiplication problem, we subtract them from 10. So 10 minus 7 is 3, 10 minus 9 is 1. The next thing we do is we multiply the smaller numbers, the 3 times the 1. And then to finish it off, we do a subtraction along the diagonal. 7 minus 1 is 6. So the answer to the original problem, 7 times 9, is 63. Notice again that we could have subtracted on the other diagonal, just take the smaller number away from the larger one. So why would anyone have come up with this? It involves doing two subtractions, then a multiplication, then another subtraction, instead of just saying, hey, 7 times 9 is 63. Well, the thing is, these days, most of us grow up learning our multiplication tables, and it's far easier for us to just do 7 times 9. But this trick was developed in the 1500s, and this was at a time where there wasn't universal education. Not everybody went to school and learned their multiplication tables from childhood on up. The person who developed this is a mathematician by the name of John Napier, and his goal throughout his life's work was to make calculation easier for people. So if you read through his books, the Rhabdology or the De Arte Logistica, you'll find every so often he's got, here's a shortcut, here's a different method. So he's giving people options and shortcuts in order to help them. And that's one of the reasons I like John Napier so much as a mathematician. So one of the books I mentioned is De Arte Logistica. So where this comes from there is from book 2 on mathematical calculations. And it's chapter 3 of that book, which is multiplication of integers. And what he says there is the multiplication of one digit by another is memorized and learned readily from the adjacent table. So here's your multiplication table. It's written slightly differently than the way we write it these days, but all of the facts are there. And below this table, his next paragraph starts, if you have forgotten the product of any two large digits, then, and what he's got below as an example is 8 times 7. And he's got a paragraph next to it explaining the process that we just went through. But the idea is, yeah, the people that are reading his book are coming to it as adults, not children. So they don't have this memorized already. And what this method does is that it allows you to take these larger numbers on the table and turn them into smaller ones. So you don't have to memorize this part of the table. You can memorize a shorter amount of material. Okay, so that is why would anyone have come up with this method? And for the third part, what we're going to look at is how does this work? So if you're interested in that, stick around. It is going to involve some algebra. So here we see what we were working on before. We've got 10 minus the 8, which is where the 2 comes from, 10 minus the 7, which is where the 3 comes from. 2 times 3 gives us the 6. And then when we subtract, we get the 5, right? So that's the process that we were using earlier. So why does this work in general? We can't just look at one example and go, oh, it's going to work all the time. So if we want to multiply two digits together, let's call them A and B. We have to make it general. So it can be any of those digits that we're talking about. What we do then is we subtract each of those numbers from 10. Well, in this situation, I would write that as 10 minus A and 10 minus B. Now, these numbers are going to be smaller than the ones you started out with, because remember, this is intended to help with those bigger numbers on the multiplication table. So 10 minus 9 is going to give you a 1. 10 minus 7 is going to give you a 3, something smaller than what you started out with. So the first thing we do is we take those two numbers at the back, we multiply them together. Okay, so this is going to be 10 minus A times 10 minus B. I'm multiplying those things I circled in orange at the back. When we multiply this out, we get 100 minus 10B minus 10A plus A times B. Okay. So that whole process is what would give us the number that goes here. But we still need that number out in front. And remember, we get that from subtracting along the diagonal. So we're either going to have A minus 10 minus B, which turns out to be A minus 10 plus B, because you have that double subtraction in front of the B, A minus 10 minus B. Or we could go the other direction, and we could say 10 minus 10 minus A, which gives us this result. Notice that those two things are the same. You have a positive A and a positive B, and you have a minus 10. The only thing is that the A and B switched places, but that doesn't make it different. Notice also that the result of that diagonal subtraction, remember, that's supposed to go to the left of the other number. Well, that's in the tens place. That's not a 5 sitting there, it's a 50. So in order to move forward with this, in order to make sure that this result gets in the right place, we need to multiply by 10. And since these are the same, I can just choose one or the other. It doesn't matter which one I work with. So what I'm going to do now is combine these two things. This is the digit on the right from multiplying over here. This is the digit in the tens place from subtracting along the diagonal, and we're just going to put those two pieces together. So simplifying, on the left, I'm going to multiply by 10. I've got 10 times B minus 10 times 10, which is 100, plus 10 times A. So that's this piece. And then I'm going to combine that with this piece, which is plus 100 minus 10B minus 10A plus AB. Wow. Well, how does that help? Well, I see that I have minus 100 plus 100. And if you combine those, you get a 0, which we could say it cancels out. Here I see a 10B, but I have a minus 10B. I have something and I'm subtracting it off. So that also zeroes out. And I kind of wrote on top of my minus sign here, but that's a minus. So I have plus 10A, minus 10A, and those both go away. And all that's left is the term A times B. Well, what's that? Well, that was our original problem. What we wanted to find the answer to was A times B. Just like over here, we wanted to find the answer to 8 times 7, and we found that it was 56. So all of that algebra work that I've done below simply shows that this process gives us the answer we're looking for, which is the original two numbers multiplied together. So as I just wind this up, I want to quickly remind you of what the point is of all this, what it was useful for. And that was for people memorizing their multiplication tables. If they forgot some of these higher numbers, they had a method of doing the multiplication anyway by turning the higher numbers into lower numbers. 10 minus 9 is 1, 10 minus 8 is 2. You're turning bigger numbers into smaller numbers. And the very last thing we're going to do is just calm it down and do one other example. So 10 minus 9 is 1, 10 minus 6 is 4, 1 times 4, those little numbers, 1 times 4, give you 4. And then you just subtract along the diagonal. 9 minus 4 is 5. So the answer to 9 times 6 is 54.